Let's continue. I did do some work off stream. No, I don't want to pass a point style. Just make it stack here or something. You can get it from the history. Yeah. The history does storage. Yeah, okay, let's pass the history then. Extremes type. So continue constructing and local extreme, which seems to take a plot and a layer and a sample. Hey, Fatman. Plot local extreme. Streams end. Also calculate history current. The past history might as well not pass. History current. Yeah, it was just added, so. Dubious, but okay. I'm going to, oops. The, what? Just pausing history here. It is a plot history. I think there's a color index. I want to change that to red, which is as usual not possible. Because nobody knows what red is. Ugh. Strange. Maybe caller 32 does not exist or something like that. Field shape. Okay, I don't know. I think 32 maybe does not exist or something like that. So let's try. Let's try first something else. Yep, that worked. So that was green. So 31 is already red. They are by default red. So now I have a green cross at the minimum here. And there, all the extremes, the local extremes get a green thingy. Okay, fun. Yep. Those are the only two fix me's that are left. So I did fix the history now. That is, the history no longer is a template. And I have a plot history, which just contains the plot stuff. And then at the moment that I add to the history here, I'm actually calling an add on the plot history. Which then calls it on the base class, on the gradient descent history, which now returns an index instead of a reference. Sorry, yeah, a reference to a sample that was just stored in the history. So then I have another array here, and then that stores plot samples. So first I just stored it in a normal history, and then I store it also in the plot samples. And we return that, so I still have a reference to something that can be used as a sample. Namely, my plot sample. It repeats these three things. Member functions of the gradient descent sample, or you can even call this to get all the other member functions. I don't know what this was, but too long ago. Just delete it for now. The kind of same thing now, right? I think I have another function now for this. the other function. No, or not. I don't know what this is. These are no longer necessary or used. Let me first commit this. Commit. What file is this? Oh, it's just a test file. Let's do this test. Oh, this is always true, so this test is never used. This is using for the maximum extremes 5 times less precision. So I want to use this instead of 0.01 in the actual test, provided that v direction is already known up there. I wouldn't know why. I wouldn't know why not. Equals, equals, equals. Oh shit. But where's the test? Oh, you get that, got past the test. Okay. Therefore, I can use it a bit. That's here. So this is always true because, well, I just tested that. And then this is always true. So the no, okay. No difference. Well, I had in the back of my mind that it would assert if I change this. And it does. So we are exploring to the left, but changing the parabolic approximation that is stored in this minimum here. And I want to adjust the scale of it, but I do not want to change the parabolic approximation itself. And I think that this function here is what I remember anyway, not changing the scale. Oh shit, it is. Okay, then I need to pass a boolean, I think, that tells it not to do any of the above, but just change the scale. That also has to do with the fact that we are moving away from the vertex. So I'm kind of surprised that it is updating the proller at all in that case. Hello, Abhishek. Yeah, I'm fine. So I could make an exception if I know how to detect this, and then pass an extra boolean, blah blah blah. But I think that the whole provision should already be there. So I fit a parabolic approximation. So we are here, right, far away from the vertex. The vertex was not found yet, and we have a parabolic approximation, and then I jump to the vertex of that approximation, which brings me closer to the vertex, and then we match another one, and I get closer and closer and closer. All that time I want to update the parabola. The approximation should be determined by the samples that are the closest to the vertex, except when they are almost on top of each other. And then I find the vertex. If then I am going to do anything at all, it's going to be continuing in the same direction, like uphill the other way. In which case I'm going away, so I do not want to change it anymore. Definitely not. I'm trying to remember where or how the code looked like that would take that into account. There was like 2 different ways. That was long ago, wasn't it? I think I had two different places, 2 different functions, and I merged them into one function. Just going to look at this function, I think. I don't see any trace, then that is just lost, I guess, in the merge of multiple update functions. No, this is my update function. Nah, sorry, I remember that it was an update function. This is an add function. Nevertheless, this is approximation 23. Add. There's nothing like it. I don't know, I'll just do it like that, I guess. I suppose I call it with something that does not match the problem, but update scale only is set. Then only this will happen. And I'm going to call Okay, that's a good question here. What number of relevant samples is... Well, that's impossible, of course. That should be definitely set. No, forget our assert there. Okay, we have this call then. Parabola scale. What this is just scale. Calling update on scale. Which is this one, and then the x-coordinates of the vertex of the new parabola. No, not really new in this case. I'm just passing the old parabola, right? We're passing parabola, which is the old parabola. I'm not updating it. But probably the same as the parabola that was still stored in the scale itself. Get the x-coordinate of the vertex of the new parabola. Parabola that was passed anyway. Pick the sample that is horizontally the furthest away from the new vertex. From which one? From the relevant samples, I guess. I already found this bug. Either the comment is not correct or I can delete the assert. Using, okay. See, here's a problem. I should update the relevant samples. Otherwise the skill update doesn't work. So I guess this should go. Should go here. Okay, now the new value is put into relevant samples. And then this is skipped, and then update is called with the relevant samples array. Which now contains that new sample. And that is unlikely further away, so it's probably also the new edge sample. So this should never happen. We're definitely not jumping to it, we're going away. See, we understand this line as well then. Relevant samples current index, the one that was last added, minus old vx apps. Yeah, that should be larger than the other one, so it's not less than. Okay, true. Doing. Then we are here. Current is, that's the one that was just added. Calculate the potential new scale relative to the vertex of the canonical parable. The reason I call this canonical is because the parabola should not change anymore. And assuming that that scale is larger, then I don't know, magic happens. And then, well, if it is indeed within 10% of the canonical parabola, it's stored as new scale. It can still go wrong, I suppose. I should probably not just test the height, but also the derivative. The derivative should also not deviate a lot. Oh, most definitely, yeah. And indeed, we are moving away from the vertex. Let's try something. Do I have a derivative in my parabola? I think so. Yeah, we don't. Okay, so this is the normal evaluation, and I want to have an evaluate derivative double something. Derivative, I guess. Double W. It's very double. And then we have return the derivative. Yeah, that's gonna be this plus 2 times that. Yeah. And then get the vertical distance from the new sample to the prober. We don't have a distance here. Difference. Let me think about that. I would rather look at the angle, but that's maybe a little bit too much calculation. What do you think about it? Okay, so we have a line, say, with some slope. And then we have another line with another slope. And then I want to know what is the size of the angle between them. Yeah, well, let's getting the cosine of that angle is probably easier. I'd rather get a sine actually. I'm expecting it to be small, so maybe I can calculate the sine of the angle and then use that, because the sine of a small angle is equal to that angle in radians. To slope, say I have my derivative, but the derivative is only one value, right? I want to picture it as a straight line. Let's straight line through the origin. X-axis, y-axis. Then this is y equals the slope times x, where s is then the derivative that I just calculated. Isn't it? I think so. Yeah. Let's call it S1. That means at this point here, at x equals 1 has a y coordinate of S1. Okay, draw another line. The other line is like this. That point here is S2. Okay, all this angle alpha. This is 90 degrees. I have still no clue. Let's call this beta. Then that divided by that. Let's ask an AI. I mean, I know they don't know it, but I'm gonna start as well. So we give a Venice and no, I'm gonna go straight to ChatGPT. Oh, that's expired. What do you want from me? That's an easy one. Yeah, though this is just y coordinate. So the y coordinate is 1 divided by square root of, etc. Yep. Yeah, if that's correct, then head off. That would be like the first time I see an AI do math like this without completely fucking up. Let's check this. To express blah blah blah. The sine of a1 minus a2, the sine of a times cosine is etc. Yeah. I don't know. Is that correct? Suppose it is correct. Would be really bad if it's called that wrong. That one bad. Wrong, I mean. It's a matter of plus or minus and stuff. And I think that if a1 and a2 are equal, then this is 0. So that seems to be correct. It's not 0 if you make it a plus. It's not 0 if you change the cosine into a sine and this one sine into a cosine. You have expression for terms of, yep. The sine of a1 is that, and that. Now we need to find expression for the cosine a1 and cosine a2 using the Pythagorean identification. Cosine a is the square root of 1 minus the sine squared a. Yeah, I guess we have to do that. So the cosine of a1 is the square root of 1 minus that is the square root of 1 minus that square divided by that. Is the square root of yeah, square root of that is the 1 divided by the square root of that. That's correct. But we already knew that because that's the x-coordinate of those points. This is the cosine. It's taking a bit of a detour here. Now we can substitute these expressions into the sign subtraction formula. The sine and the cosine, and minus the cosine times the sine. Combining these terms, s divided by that minus s2 divided by that, or okay, what? It's making an error. Unfortunately, we're almost there, but this is correct though. I don't understand this part here. It's just bullshit. This expression can be simplified further too. Yeah, really. It's still bullshit. This one can be written like that, obviously. Thus, the sign of the angle difference A1 minus A2 in terms of return is, and then it repeats it. Yeah, okay. That would still be a square root, but I probably don't have to do that, although then I have to calculate two squares. I'll have to calculate that anyway. Okay. So let's not do this. I just need the other derivative. Something is fishy here. No, it's not. Never mind. Square root of 1 plus the square of that, blah blah blah, okay. That is, well, no. It's supposed to be the square of this. Let's make this a minus. S1 squared plus S2 squared minus 2 times S1 times S2. That's the square of the whole thing. Divided by, and then that square root drops out because we squared the whole thing. So you just get 1 plus the square of S1 times 1 plus the square of S2. No square root and no sign. Well, I mean, it is a sign, but assuming this is small, I might as well compare it directly. So this is a square, so it should always be positive. And if the sign is less than something, then we do this, otherwise we do not. Yeah, what is a good delta here to accept as error? I don't know. Do something. Random. Entirely random. Maybe you should use 0.1, but on the other end it is a square here. This is square. Wait a minute, it's a square. I've got to square this thing. Whoops. Square 0.03. Oh, okay. Da, 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 da. 0.3. Although hearts. Too few arguments. I need to pass my boolean. Yeah. Yeah. Yep. Approximation of the guess is the only place. I don't know if it's the only place, so let's first try to compile this. It is. And what I need to pass is update scale only. Yeah, okay. So must pass through if I want to only update the scale, which I do if the current sample is actually on in extremes, which means that it is not on the stack. And then we're talking about I think just an approximation pointer. The approximation pointer is not equal to that object on the stack, then it is equal to one of the extremes. In which case this is unequal and I get true, which is what I want. I think this is correct. And scale looks good. So looks good. Same thing. Whatever. No crash. Did not use 5, which always annoys me, but it should be used 6 now. It does use 6. Seems to work. And now jump to 8 and then the end, I think. What? Jump back? Found global minimum. Yeah, that's a good. Tiny little difference. It should not have jumped back. Again. Unfortunately, I have to go make dinner. Otherwise it gets too late for that stuff. What else is jumping back, man? Hello, Philbert. What's up? What's up is that I have to go make dinner. I would think we get here twice. But that doesn't mean that I go make dinner. No, just kidding. I really should. But yeah. Trying to fix this last bug. Jump back. So I think what happens is we get here twice. Super sure about that. And then still we continue until we get here 3 times. I'll just print it out, I suppose. Aborting. So and then if we break here, then that break just means that we break out of pretty sure about this just while loop here. Yeah. Well, lots of programming, lots and lots of programming. And explain to me what you mean with logic, by the way. Okay, I don't know. Let me just print the. I think this rejected here means that if I press space, it's going to say that it is going to. It's aborting. Aborting going to the left, yeah. I have a very, very organically grown own complex method. So I started coding at 12 and I was seriously coding stuff when I was like 15. And over the decades I did get better. I think I was at my peak when I was 30-ish, 30, 40. And now I'm definitely going downhill because I'm just getting too old. But yeah. Tips. I mean, it's hard to give a tip in this for this. I think for in 2 sentences. Let me try to come up with 2 sentences anyway. So I mean, it's like I could write a whole book about it, or at least one could fill a whole book with this, as an answer. So it's a decades of experience. But maybe if anyone had written that book and you would read it, and it wouldn't take you that much time. Nevertheless, I would say what I always did is stuff like assuming that something already works. So you want to write a certain piece of code, but before the whole program works, you have to write 100,000 lines of code. And it would not work if you write those 100,000 lines of code before you can compile it and run it and test it. Yeah, you have to want to compile a lot, test a lot, and it must give you feedback that you're on the right track, that it works. Of course. So you have to start with little things. But it doesn't mean that you have to write. That basically, let me rephrase that. It means that you cannot write the big program. You have to write the small things first. So you don't start with. It's like literally the object-oriented thing about it. You want to write a game probably. That is super complex, but you can divide it into little parts. And the whole idea of those little parts is exactly that they work all by themselves, independent on the rest. So if you could divide your game into 1,000 pieces, or no, 100 pieces, each of 1,000 lines, then you could write 1,000 lines and then test that. And that must be, its own thing that you can test and be completely satisfied with. However, that means then that you have to understand everything of your whole program. I mean, you would have to be able to divide your program into 100 pieces, which is very hard unless you already know in advance. If you do a rewrite, that often works, I guess. Then you already know what you need. But if you write a big program and you start from the start, you have no clue yet what you need. So you also don't know little pieces of it. So then where to begin? Well, there's two things. One, if you meditate about it, there's always a piece that is the most likely piece that you can write. And if in my case, that has always been debugging support. So I wrote all the debugging support that I needed my whole life long. I put it into a library, and I'm using that library now. It's called the libcwd. I'm going to plug it, but I'm not making any money with it, so don't blame me. That's all my experience that I have that I put into the library. But it also means that you have to write a lot of user code. For example, you want every type to be printable. Every type. Because there's no way you can get your program working without very detailed debug outputs. Yeah, like this, exactly. It completely spells out what it's doing. It's almost like a trace. And that's the only way I can, at least that's how I work. So that's the only way I can understand what's going on, and more importantly, understand where and why it is going wrong. But okay, that's just one thing. Yeah. So debug output is very important, and that means that if you write a class, every class must have a way to print its own contents, and the libcwd is OStream based, so I can just write any object that I have. I can just write it to an OStream. No formatting needed, no methods need to be called. You just write it to an OStream. If you don't have that, for example, you can only print built-in types, then yeah, forget it. Just it would be at the very least an extreme waste of time to. So as an example, this is an object that is being printed. It's sample, I think. Yeah. So my sample class, capital S. If I write a sample to an OStream, then it prints this. And then I see the guts inside of sample. Know all the values. But again, so there are other things that you can maybe not debugging then, but you say, well, I'm very sure I'm going to need this or that. That seems extremely likely. Then that's where you start working on, and then by the time you finish that, you have probably much more insight about the next part that you want to write. And the final thing that I wanted to say, because that's actually what I was first thinking about, is that, well, actually I already said it, so that you write codes where you assume that things already work. So you want to write a part of your program, and you need several pieces of it, but all those pieces depend on each other, and it's kind of hard to concentrate on the piece at the bottom at the moment. Then you can just write your code assuming that everything that you don't have already exists and works. If you understand what I mean. For example, if I would write this program, I could literally begin here and say, okay, I want a window to be opened. Well, let's assume that already works. And I write this, create a window. And I didn't write window. I don't know what goes in it and how to make it work. But this is what I would like to have, that I just can create an object that is a window and I pass it a title and geometry. Yeah, so, and then say, yeah, this is not a good example because why, before writing the window, why would you understand that this is a smart API to use? But I guess I went through several rewrites before I ended up with this API. But okay, for the sake of argument, assume that it is a logical API, despite that you did not implement it yet. So you can say, okay, create a window, and then we create layers from that. So I want background layers, probably special. So I have to call create background layer, and then I can optionally create additional layers like that. This is a bad example, but really often, you just, in order to get your logic right, to get your mind not confused, you start writing code as if a lot of your code already exists and works. And what the result of that is that you will formulate how you would like it to be in terms of the interface. And that's exactly what you need for the next step, namely to implement that piece. Yeah, I think it's pretty often nice to begin with what you with your wishes. I would like the interface to be like that. If I type this, it has to work. That's my demand, and then you implement it, rather than having some abstract idea about window and then just start coding the window, because then you have no experience yet, or not even an idea yet of how you want to use the object. You just immediately dive into the guts of it. Window, yeah, XCB. I'm going to create a socket that connects with the X11 server. Yeah, no, that's way better to begin with how you use it. So before you even write. I'm going to make my dinner, so you're welcome, and I'll be back later.